Solving a triangle with the law of sines, problem type 1. In this video and a couple related to it, we're looking at trying to solve oblique triangles. And by oblique triangle here, we're talking the opposite of a right triangle. A triangle which does not contain a right angle. It could be any of several types. It could be an acute triangle where all three of the angles are below 90 degrees. It could be an obtuse triangle which has one of the angles bigger than 90 degrees. It might be an equilateral triangle. It might be an isosceles triangle. It might be a scalene triangle. I don't know any of that. All I know is it does not contain a right angle. We're going to still use the convention that we used for talking about right triangles, in that I don't know if any of these are a right angle. In fact, I'm expecting that none of them are. I don't know if any of these are an obtuse angle, but I'm going to draw everything as an acute angle just to make it fit on the page nicely. But I'm still going to be dealing with triangle ABC, and I'm still going to name the side opposite each capital letter angle with that lowercase letter. When you are solving a triangle, you need three pieces of information. In the solving a right triangle, we needed the right angle, we needed a side, and we needed something else, a side or an angle. In solving an oblique triangle, we still need any one side and any other two pieces of information. How that information comes to us in the triangle will change our approach. And we talk about how we are getting that information with abbreviations. There is the ASA triangle, where we have an angle, a side, and an angle in a row like that. There is the angle, angle, side triangle, where we have an angle and an angle and then a side. So two angles and the side not between them. These two forms are what we're going to be talking about in this video. I'll just mention we also have SSA, where you have two sides and an angle not between them. SAS, where you have two sides and the angle in between. And SSS, where you have all three sides and none of the angles. There will be separate videos that will talk about solving an SSA triangle and talking about the last two, SAS and SSS. To solve an ASA or AAS triangle, we will use a tool called the law of sines. And the law of sines is a three-piece equation. It says that A divided by the sine of A is equal to B divided by the sine of B is equal to C divided by the sine of C. In any triangle, the ratio of the length of a side to the sine of the opposite angle is constant. And so if we look at a triangle and we have some of the information about the triangle on hand, let's say that we have, I'm rotating this from what we had before just to make sure that we're not paying too close of attention to which letter is where, because triangles come in all sorts of different orientations. But let's say we have angle B here as 80 degrees. We have angle C over here as 62 degrees, and we have side length A down here at 4. Then that means that angle A, side B, and side little c are the things that matter. First of all, and immediately, the reason that ASA, angle side angle, and AAS, angle angle side, are treated the same way is that the first thing I'm going to do is figure out what the third angle is. If I know two of the angles, and I know that it is a triangle, the three angles together add up to 180 degrees. I can figure out what the third angle is. And unlike working with right triangles, when you're working with oblique triangles, you don't always have the luxury of only using the information that was given to you. So we need to know all three angles in order to work with the law of sines most effectively. So I'll go ahead and fill that in. Because very specifically what we need is a pair where I have angle and opposite side both known. In this triangle, that pair is little a, which is 4, and angle A, which is 38 degrees. I can take that information and pair it with one of the other pieces. Let's go for B first. Little b over the sine of angle B, which is 80 degrees. I don't quite have enough space to work down the page solving this, but I can multiply both sides of this equation by sine of 80 degrees to get that little b is 4 over the sine of 38 times the sine of 80, and making sure that your calculator is in degree mode because all of these angles are given in degrees. My calculator tells me that little b is going to be 6.398. I'll round that to 6.40. All right, so angle A was 38 degrees. Little b is 6.40. And let's clear out some space. Working on a sheet of paper, you probably just have more paper you can turn to. I don't have that luxury, so let's just get this out of the way and repeat the process with side C. I'm going to stick with my side A over the sine of angle A because I trust my calculation of angle A a lot more than I trust my calculation of side B. But now I'll ignore the middle part of this three-part equation and write that this is equal to side C over the sine of angle C, which is 62 degrees. Multiply both sides of this equation by sine of 62. Punch that expression into your calculator, again, paying attention, making sure your calculator is in degree mode. I keep repeating that because we will be using degrees and radians, and the most common mistake in trigonometry is having your calculator in the wrong mode and getting an angle in the wrong kinds of units, which just throws everything right out the window. All right, but punching that into my calculator, I get something in the ballpark of 5.74. So by using the law of sines, I'm able to solve this triangle. Again, if I had had this as an angle side approach instead, my first step still would have been to find the third angle, and then I have all three angles. I find the matching pair of angle and side, and then I go from there.